Now we go to the next parameters, which is very important in thermodynamics, is the pressure. Of course, what is the definition of pressure? Pressure is equivalent to force divided by area. Okay, and we could have a lot of units which refers to pressure. We have Pascal, we have bar. Just now I have mentioned about 1 atm or P atm, whereby the unit is the value is 101.325 kilopascal, or this is in terms of Pascal. Okay, so we can convert also the atm in terms of kilogram force divided by centimeter square. So how to get the pressure? We use gauges to measure pressure. These are example of gauges that we have in different scale. And if we look at this type of gauges, they are also known as the Bourdon gauge. Okay, these are called as Bourdon gauge. Bourdon gauge always give us the reading of gauge pressure. Example of Bourdon gauge that we could find is in petrol station, whereby we pump in our air, compressed air inside the tire, inside the car tire. These are the physical appearance of the pressure, where we could have what is being called as the positive effect of pressure. So this is our atmospheric pressure. This is our absolute pressure. Okay, when we have the atmospheric pressure is greater than the absolute pressure, so what do we have inside the tank is called as the vacuum pressure. Okay, vacuum pressure. This is the case of P atmospheric is greater than the P ABS. Okay, P atmospheric greater than P ABS. So this is the equation that we refer to. So when we have P ATM greater than P ABS, the difference between these two is called as the P vacuum. For a P whereby we have the P ABS is greater than the P atmospheric, so this is the case for P ABS greater than P atmospheric. Okay, as though that the pressure inside a cylinder or any closed vessel, as though that the thermodynamic system is trying to get out of the tank. So this is called as the gauge pressure. So the difference between PABS and the PATM, okay, PABS and ATM is called as the gauge pressure. The easiest example for vacuum pressure is the usage of our vacuum cleaner in our house, whereby we create vacuum inside, vacuum pressure inside the vacuum cleaner in order to suck all the dirt or all the debris from our floor, right? Where else, for this case, where the PABS is greater than the P atmospheric, for example, if we blow a balloon with air, so when we blow or we charge in a balloon with air, then the balloon will be increased in volume because of the air inside is pressurized. Okay, inside the balloon is pressurized, so we know that the balloon is subjected to explode if the pressure is too much for the strength of the rubber made for the balloon. So it could burst, it could explode. And that type of pressure is called as a positive pressure. This is vacuum pressure, and this positive pressure is referred as the gauge pressure. Okay. And when we see pressure varies with depth. Okay, with depth. Let's say we have a pool or a tank, whereby at the top of this surface or the pool, we are subjected to the atmospheric pressure. When we go down to the depth of this water level, we could find that the pressure will increase. Okay, the pressure will increase. So at certain level, we have different type of gauge pressure. It all depends on the height of the liquid on top of that level. The more we go down, the higher is the value of the P gauge. Why? Because we know that the P gauge right here is depend on the depth. The P gauge is equal to rho g h, whereby this is our H value. More H, more gauge pressure. But the P atmospheric is still the same. Okay, the P atmospheric is still the same. What is actually P atmospheric? The P atmospheric actually what we have on top of that surface. Okay, let's say we have cloud, we have air. So the dense or the weight of the cloud, the weight of the air will be used to define the P atmospheric. So this is P atmospheric, what we have on top of us, or on top of a certain level, in this case, this surface, subjected to P atmospheric. And when we go into depth, then we have P atmospheric, and also we have the P gauge. So in this case, we could write that the PABS is equal to the P gauge plus P atmospheric. Two types of pressure subject to the level that we look. In this case, if we look at this level, so the gauge pressure should be rho GH. So that is the variation of pressure to depth. For example, we have one container. So this is our pressure because of the air plus whatever we have on top of the level. Okay, whatever we have on top of the level. So this is referred as the P atmospheric. So this is the case. Then after that, when we go down, the pressure increases when the H value increased. So what is the level, the pressure of this level, which is called at the PABS at this level? Then this is equal to P atmospheric plus rho GH. So if we have a lot of water, a pool of water, right, but we have different level, as far as the level is concerned, if they are the same, the pressure is the same. So if we have A, B, C, D, E, F, G, same level, pressure is the same, because we are looking at the same height of the liquid and the same level. Then we have right here, this is P atmospheric, this is our P gauge. So the pressure at this A, B, C, D, E, F, G is P atmospheric plus P gauge. But if we have the level of H and I, we have mercury and also we have water. We have two P gauge. We have two P gauge. This is a P gauge because of the water. Then we had the P gauge because of the mercury. Apart from that, we also had a P atmospheric right here. So what is our pH? pH is equal to pHg plus P, G for water, and plus the P atmospheric. Whereby for the PI right here, we only have one liquid and atmospheric. So this is our P gauge for level L. And this is the height for the P gauge from this level to this level. And again, we have the P atmospheric here. So what is our PI? Is equal to P gauge because of the water plus the P atmospheric. So if we have different liquid, different P gauge, so the pressure of H and I is not the same. Okay, in this case the pH is not the same as the P at the location of I. This is Pascal law, how we use the pressure to increase or to elevate a certain object which is very heavy. Now we go for the barometer. What is a barometer? The barometer is a device that being used to measure the atmospheric pressure. Okay. And we see at point B right here, the point B right here is subjected to atmospheric pressure. So if we look in terms of the construction of the barometer, we can see that this is a column initially filled with liquid, and usually in barometer we use hydrogen or mercury. So when we immerse the opening of this column into a bath of mercury, then we can see that because of the weight of the mercury, the upper part of this column tends to have a vacuum. Okay, a vacuum. So this vacuum, or the height of H, okay, the height of H is all depend on the atmospheric pressure. So this is subjected to atmospheric pressure. P atmospheric, this is also P atmospheric. So when the P atmospheric is high, then the H value or the volume of this vacuum is become less. So the H will increase. So the H value always differs when the P atmospheric changes. So this is the formula whereby we use this type of barometer, and we use this formula to get the P atmospheric. Okay, and we have different size of column, the P atmospheric is still the same. Next we go for the manometer. This is a manometer. A manometer usually being used to measure P gauge. Right? So if you want to know what is the P of this gas, the P of this gas, the whole gas is subjected to the same pressure. So what is P gas? The P gas is equal to the P1 right here, the beginning of the manometric fluid inside this U-tube. This is called manometer. And when we transfer based on the variation of height, that we know that when the level of water, of liquid having the same level, the pressure is equal. So we know that this is the P gas. P gas is equal to P1. When we look at this same level, this is our P2. And in this case, the P2 is equal to P1. which equal to the P gas. So what is P2? P2 is this P gauge, and on top or at the surface of this manometric fluid is subjected to the P atmosphere. So what is P2? P2 is equal to the P gauge plus P atmosphere. So remember, this manometer is for calculating to get what is our P gauge. So example, at different level, this is P1. How to get the P1? P1 is equal to rho GH or the P3, P gauge 3 plus P gauge 2 plus P gauge 1. So what is a P1? Also can be written as the rho GH3 plus rho GH2 plus rho GH1 plus P atmosphere. So that is P1. Okay. This is other type of pressure gauge. As far as we are concerned, either the pressure gauge is given in any problem, or we measure using the Bourdon gauge or the manometer. So this is principle used by a Bourdon gauge. Okay, so I think that's it for the lecture of basic concept in thermodynamic and fundamental of thermodynamic. Okay, bye. Okay guys, thank you very much.